Welcome to the Web Platform Podcast, a developer discussion that dives deep into all things web. We discuss topics relevant to developing for the modern web and the web platform of today, tomorrow, and beyond.
This is the Web Platform Podcast, episode number 78, The State of WebAssembly. It's kind of hard to believe we've done 78 episodes so far. I know. Apologize for everybody that's listening. It is taking us a little bit longer to get them out on iTunes, but everything is coming out on YouTube just fine. So today we're going to be talking all about WebAssembly. I am your host this week, Danny Blue, and we have a pretty big group of people with us. So starting with Justin, we're just going to go around the proverbial room and introduce ourselves.
Hello, I'm Justin Ribeiro. Hello, wonderful people.
Short and sweet.
No one wants to hear me talk.
Yeah. Go ahead, Sharon.
Sharon DiOrio, front-end developer, primarily in educational technologies. Happy to be here.
Hey, I'm Jeff Bastien, compiler engineer on Chrome.
Hi, I'm Luke Wagner. I'm a research engineer at Mozilla.
Hi, I'm Brian Terlson. I'm a program manager on the Chakra team and do a lot of work on ECMAScript.
Hi there, I'm Gaurav Seth. I'm also on the Chakra team. I'm a PM on Chakra and TypeScript.
I'm Louis Lafreniere. I'm the dev lead for the bit on Chakra.
Abhijith, I'm a lead for the language team.
Awesome. Well, thank all of you guys very, very much. And what I'm not supposed to say is I just use that as an excuse so I didn't have to try to pronounce and say everybody's name. I got away with it, so thank you all very much.
You always say my name wrong, Danny, and it kills me. Every time, Justin.
Okay. So, all right, like I said at the beginning, we're going to be talking about WebAssembly. So, whoever wants to start off, somebody please tell us what WebAssembly is.
I'm going to nominate Luke for that one.
Okay, well, I was thinking maybe I would just read from the high-level goals. Our goal is to define a portable, size, and load time efficient binary format to serve as a compilation target, which can be compiled to execute at native speed, taking advantage of common hardware capabilities. So, compile target for the web. Initial goals, let's support some of the features that are in ASM.js and provide a really good compile target for C++. But then after that, let's generalize and support more languages, more use cases, and evolve from there.
Awesome. So that sounds really cool. I think compile target for the web makes a lot of sense and is pretty easy to understand, especially with how many things are out there that now compile into JavaScript. So is that how this kind of came about? Because there are some, with TypeScript and Elm and CoffeeScript, so many things are compiling into JavaScript. Is that where the need for something like WebAssembly came up?
Well, it's funny. The origin of compiling C++ to JavaScript actually alone says that he saw people compiling all these other things to JavaScript, and he said, "Why not C++?" So he just tried it, and it worked surprisingly well. And that was way before ASM.js. And then after he made that, it worked. Then people started using it for bigger and bigger things, and we started optimizing it, and they started using it for bigger things, and we decided to, let's see how far we can push it with optimizations, and that's where ASM.js came from. But ultimately, it's just people have big C++ code bases, or at least this is one of the use cases that really kind of got this started. Is they have huge C++ code bases they've invested, millions of dollars into creating, and they just want to port it to the web like they port it to all sorts of other platforms.
Right, and I think it's not like all languages that you want to compile to WebAssembly. Things like TypeScript are probably a really good fit for JavaScript, right? So I think what we're trying to do with WebAssembly is to make our lives easier as compile engineers so that the JavaScript engine doesn't have to jump through hoops, or the compiler targeting JavaScript doesn't have to jump through hoops to express things that fundamentally are kind of a lower level, but languages like TypeScript are actually pretty well suited for targeting JavaScript, right? It's just, as a developer, you want to use a language that's maybe slightly different from JavaScript sometimes, and that works pretty well, right? It's just things like C++ that predate aren't really a good fit for dynamic languages. So I think there's kind of a weird distinction here that we make. Obviously, we don't mandate that you do one thing or another, but that's really the target we're trying to aim.
Awesome. I think that makes sense. But so you don't. So when I first heard about it, what I kind of envisioned is that eventually everything would compile into WebAssembly. All these other languages would go into WebAssembly. But so it sounds like that's not necessarily. It's not always the best. It's not always the best use case for everything when you're talking about something like TypeScript, or is that just because TypeScript is parts of it are so close to JavaScript? Like, do you think that people will start making brand new, brand new web languages just because they have this new compile target?
So definitely, I think people are going to start making new things. But in V1, I think the memory model of WebAssembly is just this low-level linear memory model that you kind of only have with C, C++, and Rust is another example that has that same linear low-level model. But if you look at the future features of WebAssembly, we do want to offer direct integration with the GC that's already in the browser VM. And so that would allow WebAssembly to refer to the same GC objects that JavaScript is able to refer to. And if we can get standardized typed objects in JavaScript, then we'll even have a fairly efficient way to talk about the same structured objects. So I think in V1, you're going to have a hard time compiling much other than like low-level type languages, but in the years that follow, as we add more features to WebAssembly, it will be a suitable compilation target for GC languages.
Right. I think we don't really know what people are going to end up doing with it, and what are the 700 next programming languages that will come out of it. I think what we're trying to aim at is create something that, from experience, we know is painful, both to target JavaScript as well as to compile JavaScript efficiently. And we're trying to meet the needs of C++ as well as other languages that we're familiar with. But as Luke was saying, we want to do a simple thing first and then evolve it forward. And we don't have a clear roadmap of all of the evolution. We have a pretty good idea, but as we create things, I think other people will kind of teach us really what we need to be doing in the future evolution of the language.
I think another key point here is that WebAssembly and JavaScript are going to be sort of what you can kind of think of WebAssembly like a feature of JavaScript. It's not like you wouldn't consider compiling JavaScript to WebAssembly to run it on the web, because JavaScript already runs on the web, and TypeScript is very close to JavaScript. So clearly, TypeScript compiling to JavaScript will continue to be a good option even with WebAssembly. There will be a bunch of languages that probably choose to continue compiling to JavaScript. That'll have a pretty good experience like it does today. But WebAssembly just sort of opens the gates, I guess, and makes a lot more languages practical and performant to run on the web.
I think that's one of the misconceptions I hear often, is that people assume that we could make a really fast JavaScript by compiling it to WebAssembly, but there's really not a whole lot of advantage to do that, because the dynamic nature of JavaScript is what is part of the overhead, and WebAssembly enables languages that have a lot more static type information to run fast in the browser, but having JavaScript there would not be much of a benefit.
So there's a lot of talk about, WASM.js and sort of where things started down this road, and there's a lot of sort of precursors to before we get to WebAssembly. What are some of those changes now that are coming in the design process that sort of make WebAssembly more flexible than WASM.js was?
Well, one thing is it removes a constraint that we had with WASM.js, which is any feature we might want to add that we support this kind of possible AOT compilation. We had to think of how do we constrain the JavaScript pattern so that way nothing can go wrong at runtime. And that was a pretty huge constraint, and we faced that big time just with heap resizing. When we had to add that one, that came up with a pretty gnarly constraint. And so going past that to do things like dynamic linking or even other stuff we've talked beyond that is would be a challenge. So it avoids that kind of constraint that this two-role, where JavaScript is kind of serving two roles, being a language you would want to write by hand and be good at that, and then a language that describes an AOT compilation target. So it makes it just easier, I guess, to add new features.
There's also, in terms of performance, the fact that JS is not the smallest representation of a program. Assembly, we can
Hey guys, we're having a little trouble hearing you. At least I am.
Yeah.
Maybe we're a little too far.
Yeah, you can move in a little bit closer to the microphone.
There we go. You're off the screen now, though. I was just pointing out that ASM.js is not a very compact representation for program versus WebAssembly. With the binary format, we're going to be able to have much more compact programs. Is it better now? I guess not.
It's a little bit better, yeah. Okay, so we've said ASM a couple times. I'm just as confused about what ASM is as I am about what WebAssembly is. So can somebody kind of explain what ASM is and what ASM is, what it is for, and how it relates to WebAssembly?
Sure. So I guess so often when we say ASM, we mean ASM.js. Although sometimes we say ASM to mean either ASM.js or WebAssembly. We don't care which one. It's that compiled target thing. So when we're talking about ASM.js, we're talking about just JavaScript semantics, like the same meaning is defined by the JavaScript standard, just imposing this extra type system on top of it that constrains it such that it's super efficiently compilable. And yeah.
Right. Whereas I think the ASM in WebAssembly is more we're more trying to express kind of low-level concerns, like what a compiler IR would end up looking like, right? The type of opcodes we'd have, the very, very low-level details that map pretty nicely onto different architectures. So the idea of WebAssembly is the instructions that we expose in WebAssembly itself are really, really close to what hardware ends up having, what different machines end up having. So it'll map really nicely onto x86 or ARM or MIPS or other architectures. And the idea there is WebAssembly is really a compilation target, right? So you can write it by hand, but we really don't encourage people to do that. I mean, you can do it all you want, but the main point is it's meant to be generated by a compiler, just like a compiler generates, low-level assembly. And then there's a two-step compilation process where the browser receives this WebAssembly package and then compiles it to an actual ISA like x86 or ARM, something like that. So assembly.
Getting connectivity problems.
Yeah, no, we're having So everybody that's watching or will be watching / listening, forgive us. We are troubleshooting some technical issues at the moment. Okay. Hey, Justin, can you Mark? Justin, can you drive real quick? I need to put out a work fire.
Okay.
Thank you.
Let's drive, people. So we're talking about. So there are differences in it, and I think there's a lot of there's a lot of high-level goals that the project has overall. One of which is the polyfill. So a lot on the web platform, we talk about the low-level primitives, and we want to bring those primitives to life, sort of with the extensible web manifesto that's out there to help web developers have more options and that sort of thing. And one of the things on the WebAssembly list that I find interesting is the polyfill, which is a high-level goal. There's a few demos that have been released that show promise. I mean, what are some of the challenges of bringing polyfill to sort of this grand scheme? I mean, because polyfills are really, really hard. And sort of what are the challenges around that?
Well, one of the useful things is agreeing that we want a polyfill for V1 helped constrain the design space of the V1 of WebAssembly to say that which we can polyfill to WASM.js. And if you're thinking about like starting a big new project, it's easy to have an exploding scope so that you can't pick what exactly we're going to standardize. So having WASM.js as a polyfill be a kind of a design constraint was useful in that way.
And it's going to pick up some speed, correct? I mean, realistically, with the Streams API sort of in the pipeline, that'll give you the ability to sort of read as streaming downwards, correct?
Yeah, well, that's a funny point. Is even before there's any native browser WebAssembly support, you may find people wanting to use the WebAssembly binary format just because it saves space over the wire. And yeah, with the Streams API, then the overhead could be low. Because you're able to be decompiling it to WASM.js as it's being downloaded. So yeah, that's and in fact I think we might already even have some people shipping, and it's just any sort of binary format that compresses WASM.js and then decompresses it on the client.
So in terms of, we've talked a little bit about sort of the high level sort of thing, and we've got this sort of initial target focus that is on C, C++. What I wrote in the show notes reminds me of WebC, which I'm almost positive no one remembers from the late 90s because I'm old. And it was a really niche sort of project, and it's definitely not this. However, this sort of C, C++ world doesn't leave JavaScript developers in the cold. We sort of covered that. But how are JavaScript developers going to be able to leverage some of that power that WebAssembly is going to bring?
So I think even before WebAssembly is released, we see people doing this with WASM.js, which is packaging up C libraries or C++ libraries into JavaScript libraries. So people have taken, compiled some encryption code or physics engines or audio codecs, and they wrap that in a JS library that gives you a nice, familiar JS interface, and then JS developers can reuse that en masse. And we even see some frameworks starting to experiment with using WASM.js to optimize things that you might traditionally associate totally outside of the domain of WASM, like implementing HTML templates and other sort of the data flow analysis that has to go on to propagate changes. So I think a lot of people will end up leveraging it indirectly through libraries and frameworks. Now, as we move forward, evolve forward in the future, and have more direct access to GC, then you can have different new types of languages that developers write in directly that targets those GC types.
Right, and I think where it'll be interesting is, as browser developers, we kind of need to make that blurring of the lines between JavaScript and WebAssembly really easy for developers. So it needs to be easy to use both together and be able to debug through it, or use view source if you just compile it yourself or something like that. There's a line between WebAssembly and JavaScript, but we want that transition to be as easy as possible, right? And so if you just downloaded a framework that implements some video editing tool or some image manipulation or something, it should be really easy to use in concert with JavaScript, right? You can kind of put the line there between the two wherever you want, and the browser should make it easy to use both types.
And that's sort of, I think that's an intriguing sort of concept, right? The idea of sort of bridging that gap, right, to make it easier. Because there's not, I don't know the percentage of web developers who are out there writing C, C++ right now, but I can't imagine that it's very high. And not to say if you're writing C, C++, hey, you should go work on a browser somewhere, because I know there's a lot of tickets to be fixed. Wonderful people of the web community out there. But with ease comes, you start to see, I think about easiness, and I think, oh, tool chains and backends and wonderful things. WebAssembly has started on Clang and LLVM. Are other compilers going to come on board? Is it going to be, somewhat seamless to do these things out of the tool chains that you may already be using in the C++ world?
I think so. I mean, we can't really speak for other compilers, but the reason we started with Clang and LVM is because we're just more familiar with it. The people working on it, myself, other people at Google as well as at Mozilla, that's what we're used to, right? And so for us, it's kind of easy to get up and running. At the end of the day, a compiler's a compiler. They have kind of different ways of doing things. I surely hope that other compilers will be able to target WebAssembly, but right now it's kind of a moving target also, right? So if you have a compiler today that does C and C++ and you want to teach it about WebAssembly, well, you're going to have to keep up with the changes in the standard. So it may be easier to do once it's standardized or something like that as well. But I think fundamentally it's easier to target WebAssembly for a compiler than it is to target another architecture, right? It is another architecture, but it's a fairly simple one at that. So I don't think it'll be that much work, but we'll see what happens.
And what would you say is driving the spec today? I mean, obviously there's a lot of people involved in the spec writing process, and spec writing processes can be quite hard, depending on what your feature set is, what you're trying to accomplish. Looking at sort of the targets you want to meet, and you guys have, in this call have sort of spoken to that thing about we've tried to keep V1 very small, or as small as it can be, that gives us the amount of features and the amount of expansion that we may need on the web platform. I mean, what are some of the roadblocks right now that are in the spec process that just haven't been sorted out or are in the process of being sorted out?
I wouldn't say. I mean, I guess I'm not aware of any roadblocks. We have sort of we've broken up the process and first agree on what are the core set of operators and their semantics, like what's the meaning, and then after that focus on how do we represent this tree of operators in a binary format, and that's what we're focusing on now. And this is just a period of just everyone implementing an experimental version, seeing what feels natural, what feels wrong, and then fixing what feels wrong, and then getting some agreement on that. And then after that, then there'll be a big focus on, okay, what's the textual representation of this same tree of operators? And so that we'll see in the dev console when you open view source or pull up your debugger. So those aren't roadblocks; those are just the phases of of standardizing this. But you're right to say at the beginning we've tried to maintain like a ruthless focus on a minimum viable product and not kind of feature creep too much. Yeah.
I'm bad at words. Roadblock was probably really the bad word to use in this scenario. So I want to apologize to our panel and our audience because Justin is not good at the words. Sorry, please continue.
Oh, yeah.
Or somebody else. Any other thoughts on that particular topic of standardization?
Right. Well, I think the main way we've approached this is we have similar experience in implementing VMs, and so we kind of agreed pretty early on a basic set of opcodes, like Luke was saying. But the rest is all kind of up in the air, right? Like the text format, we have a thing that looks like Lispy S expressions right now. We don't know if that'll be the final format or not, and to a certain degree, it doesn't really matter. That's not what you're shipping, right? That's not the product. What we're really focusing on now is getting a solid binary format down and making sure that it can decode fast, it's small, and that it's extensible. So that as we evolve WebAssembly forward, the new features come on and they don't look like they don't fit in the binary format. I think those are the main things we're doing now, and really what's driving the development is implementation, right? We're all busy implementing different parts of it, and as you implement it, mistakes you made. So you just go into
And to that point, I think you bring up a very valid point, which is, the binary format needs to support the features that the platform needs to do. Because I know that there is some question as to why not use LVM's bytecode, right? Why not just say, oh, well, we'll use the bitcode as the binary format from LVM? But that's not necessarily one-to-one, correct?
Right. So we actually have experience doing exactly that for Portable Native Client, and it has upsides and downsides. So Portable Native Client didn't actually standardize LVM's binary format per se. It's a subset of it. The subset is actually quite close to what WebAssembly has, but what it looks like is actually very similar to LLVM's. And LLVM wasn't designed to be an intermediate format to ship around the wire because it wasn't designed to be stable. It was designed to be a compiler IR, and we can't just go in and impose on LLVM, hey, you should stop changing things now because we decided to ship your stuff, right? That's one thing that we can't do, and then there are a lot of kind of really small shortcomings that kind of end up piling up. The IR itself has some C++ isms in there that we wanted to kind of change, and the binary encoding itself isn't that great either. We think for WebAssembly's purpose, we'll end up doing kind of a better job than what LLVM has, because LLVM just isn't suited for just transferring over the wire and being compiled by someone else later and something like that. So overall, it's just a question of designing a binary format from scratch it's a good amount of work, but I think it's the right thing to do, right? We'll end up with a much better product at the end.
Other thoughts and things on that? Anybody else? Wonderful. So let's, we've kind of talked about, how this affects the web in general. How does this affect web developers? One thing I'm interested to hear about is that it actually is going to have a view source sort of function. A lot of web developers out there who are sort of learning the web, view source and dev tools and those sorts of things are sort of a key component to sort of shrinking or at least helping you understand quickly what other people are doing, like how the world works around us. Are there other things within sort of the WebAssembly spec that you think will help web developers understand better how the WebAssembly works, but also how VMs work in browsers today?
Well, I think on the view source side, it is a goal from the start that when you, in the browser, you execute a WebAssembly module, the way we want to design the binary format and the text format are kind of almost isomorphic to each other. So view source would just be, here's the binary format, and it's normal to show you the textual representation of it. The same way, if you're used to C or C++ code, like you can obj dump a C++ source file and you see the corresponding assembly, right? The C++ executable and you see the assembly. Now, that doesn't mean you see the original C++ code, right? If you have debug info, you'll see that, and that's something that we want to support. But if you don't have debug info, you're kind of, you can see a few symbols, but all you get to see is the assembly. So the source you see is the executable, the source equivalent of the executable.
So this will be a way for people to obfuscate their code in the way that JavaScript doesn't really let them do that.
Well, actually, on that point, ASM.js kind of allows the same degree of obfuscation. And I mean, when you look at basically the view source of a big ASM.js compiled app, it's just really difficult to make kind of heads or tails of it because it's all about loads and stores from different offsets. So in that respect, it shouldn't be any worse than ASM.js. But on the flip side, we want to do a lot of work to support like basically improved source maps or things in that direction that will allow you to see the original source code. And that's not a V1 feature, but that is something that many people are interested in, so that when you view source, if you compile from C++, you see your C++.
Right, because I think source maps isn't like, so coming from as a C++ developer, source maps is kind of the equivalent of debugging with line maps. So you see like, well, this assembly line comes from this line of C++ code. You don't really get to see the actual C++ code unless you have the source code, right? And what we want to do for WebAssembly is make debugging much easier, kind of build it into the tooling. But have it on the side, right? So that like when you download an executable just as a regular user, you're not downloading all that debug info, right? It's a thing you can slap on the side, and so you can debug it. You can offer it to other people to debug it, but by default, like a random user using just their cell phone doesn't get all the debug info. That's kind of a waste of bandwidth.
Do you see the actual process that web developers go through now being that much different, except for this extra compile step?
I think for people using JS frameworks, that would be the way they leverage, these compile technologies, and so in that respect, it would be the same. You're using a framework, you're using a lot of the libraries it provides to you. For users using something like TypeScript, if we can imagine extensions to TypeScript that could allow you to opt in to say this module is fully statically typed, you could imagine that that would be a more direct way to generate WebAssembly is from languages that offered fully kind of statically typed use, like modules, and that could compile to WebAssembly. But that'd be a little farther down the line.
Okay.
There was an interesting point earlier, a question of will this help people teach VMs? And I think that one actually, I can see a lot of kind of cool tutorials where you're compiling WebAssembly from some toy language as part of a teaching, like of how you teach compilers. And compiler classes usually do that, but the fun part of this one is what you're compiling to isn't, usually they teach MIPS because it's really simple, but here it could be WebAssembly that runs in your browser, so you could write your compiler in JavaScript to WebAssembly and then run that in your browser and have the REPL and the dev tools all be in your browser. So that actually, I can see some school courses or online courses taking advantage of that for great justice.
I probably would have studied more if that was the case in compiler class. I'm horrible at it. Horrible. That would have been way more intriguing to me.
Right, and basically, because we're compiling C and C++ code, it should be kind of easy to compile, big compilers into WebAssembly and then self-host in that way, right? It's not super useful for, most people on the planet to be able to do that, but if you want to learn programming or if you want to just use stuff in your browser, it's actually quite nice, right? It's a nice academic thing, but it's also useful.
So, when we talk a lot about, we know it's a long process. We know we're in the demo stage of testing in things. There's some demos out there now that sort of show off some of what's going on WebAssembly. I mean, when do we think this might happen? There's some specs get sort of bogged down in mailing list like nightmares. Over the years. I mean, when might web developers be able to start using WebAssembly to, some degree? Which is a really mean question to ask, by the way, and I'm aware of that.
Dates. We need actual dates.
Well, we don't really have a date. We have an idea for the feature set we want as a minimum viable product, but part of it is we want to take the time to design things like the binary format really well. And we have something binary format-wise that's pretty good right now, but it's not something that we believe we'd want to ship, right? So if you use the beta versions of different browsers, or at least if you download the browsers and you compile their source code, you can play with stuff right now. But I definitely don't recommend shipping anything there because we're going to change it and we're going to break you. So yeah, it's kind of sad, but I think it'll be ready when it's ready is more the thing, right?
But there is a lot of active experimentation, I think, in all the browsers, and you can see that publicly just in the source code that's landed in all the repos. So I think at the stage in which people are investing the effort to start prototyping limitations, that's actually really encouraging compared to a lot of other kind of web standards. So I think we actually have a large amount of momentum, which makes me hopeful that this won't get bogged down in mailing list hell or anything.
So, a lot of I think back to the wonderful face-to-face meetings of the Web Components days, which are ongoing, as we try to sort out a lot of what happened with the various specs that sort of combined to give us Web Components. I mean, are there any face-to-face meetings sort of in the works to work out the contentious points? I always feel like there's a contentious point somewhere. Some are much more angry than others. A la Shadow DOM, which if I see Danny going, oh my God, Justin mentioned Shadow DOM again. But it's true, there was contention, and then there was face-to-face. Do we have any face-to-face meetings planned for the WebAssembly?
Well, so we're kind of operating under the W3C community group umbrella, and so far that's worked out pretty well for us. We end up kind of having ad hoc discussions on IRC or something, and sometimes we end up meeting at conferences. For example, we're going to FOSDEM, myself and Dan Goldman from Mozilla next week, and meeting face-to-face and talking to other people there. Same thing around the LVM Developer Conference or something like that. And that we found that that's been a pretty great way to get input from not just people who would help us develop what we're making, but also people who'd want to use it. And we haven't really tried to get kind of a bigger official WebAssembly thing going yet. And it'll happen in the future, but for now it's worked out pretty well. So yeah, we haven't really tried anything.
Cool. Now I'm with Justin about the. I'm sure there are there's something about the spec that people don't agree on, and it's as the way with the internet. It's much easier to get angry at things online, and a lot of times when you're like, oh, there's just a person that has a valid point of view on the other side. It definitely helps. At least in my experience, there are less quote unquote screaming matches in person than there are over the tubes of the internet. So I'm kind of curious if we think that WebAssembly, because I mean it is called WebAssembly, it is geared for the web, it is geared for browsers. Will it find use, or does it have utility outside of the browser? Like, will there be another server-side language, for example, like another node that compiles into a WebAssembly type deal?
So I don't know if we want to create another node, right? Like our main goal is to create a VM that'll allow you to do stuff. If people want to go and create another node, I guess the same way Node came out of JavaScript, Brendan didn't say and then create Node people, right? Like people may create that despite us, but there are a few Node.js people involved in the WebAssembly community group, and I think that's more productive. If someone else wants to go create a non-Node-based WebAssembly thing, that's cool too, I guess. But I think there are definite use cases to use WebAssembly outside of the web, and I think the reason web is in the name WebAssembly is more because of the principles of the web, right? You want it to be kind of ephemeral, you want to have pretty high security, but you want it to be portable. And that's kind of the philosophy that's driving the design of the VM. And I think pretty soon we'll see non-browser uses of it. The same way, for example, your native client was used outside of the browser, there's really no reason you couldn't use WebAssembly outside the browser. And it's an explicit design goal, if you look at our design repository, to make that a possibility.
Also, just like JavaScript doesn't have explicit dependencies on the web, you have these sort of hooks in the standard of the host environments, and WebAssembly is being designed the same way.
Yeah, so I mean, the only thing I would say is wherever VMs can go or JavaScript VMs can go, WebAssembly should go to those places essentially.
Awesome. No,
and it is high-level goal number 4, right, on the list of design support non-browser embeddings as well, because I love me a good doc.
No, that's awesome. It's definitely the most, especially with how much, I don't know if you would say grown up, or how much different JavaScript is now from where it was. It's good to know that other things like this will be as portable as the language itself has become, which is really, really great. So now I've avoided asking this question the entire time, but especially when the announcement first came out, and I think we've answered this already, but I need an explicit answer. Is WebAssembly replacing JavaScript?
Nope.
No.
All right, that's all I needed. I don't need any more than that. I just needed to know. Yeah. So
I think one interesting way to phrase it is, right now, when you compile to JavaScript and stuff like that, you're kind of shoving a lot of stuff into language that wasn't really designed to do that. And WebAssembly's there to, kind of take over that burden from JavaScript. You can still do it in JavaScript, right? But it allows JavaScript to shine. You really get the JavaScript VMs kind of concentrating on actual JavaScript use cases instead of trying to serve multiple masters. And then WebAssembly is designed from the start for those use cases. So it kind of offloads JavaScript, but it's not replacing it. Actually, if you look at the APIs in the browser embedding, they'll be pretty much the same for JavaScript as for WebAssembly. So there's a big collaboration. It's more of a sidekick type of thing than a replacement.
Okay, no, I agree. I think that's a good way to put it. But do you hear that, Internet? No, all of your precious JavaScript knowledge is still valid. It's not obsolete.
Danny, just start learning C++.
Calm down. I tried.
There's no reason not to learn it. It's simple.
Ish. On this subject, Brendan Ike has a little mantra he'll use of one VM. Like it's one VM, two different ways of putting code into it.
No.
Although he had to change his tagline from "always bet on JavaScript" to "always bet on JavaScript and WebAssembly."
And
I saw that.
That's pretty good. Will there ever be a reason to just write vanilla WebAssembly code?
If you're a compiler author, or maybe you're writing some glue code or some standard libraries, maybe. But it's sort of like how often does a C++ developer handwrite their x86 assembly? It's pretty infrequently.
Personally, it's pretty often, but that's what you get when you work on compilers, right?
Yeah, no, I was always very curious, and I am curious, especially to see how some of that stuff works, because it's referred to as a subset, right? So like, does it look a lot different? Does it feel a lot different? Things like that.
One fun thing in MScript you can do today is, in C++ you can have assembly blocks where you write some inline assembly in your code. Well, the assembly when you compile to JavaScript is JavaScript. So in MScript, and your inline assembly is you write JavaScript inline in your C++, and then it bottles it up and puts it all in the final JS. So yeah, JavaScript is the assembly of MScript.
I believe our LVM backend currently supports exactly the same thing. So that's it's kind of cute.
That sounds terrifying.
It's kind of funny. You put a console.log in the middle of your C++ code.
Yeah, no, it feels wrong. I don't like it. I'm uncomfortable. But no, sorry, Sharon, do you have something?
No.
Okay.
Just laughing at your jokes.
But yeah, all right.
That's a first for Danny.
It is true.
Danny right now there's going to be badges later.
Yeah, it's
in
true.
honor of this.
He just looked so horrified. It was great. You should do that regularly.
That's just my face. The constantly terrified face. So, all right. What's something that I don't know? So we've talked about WebAssembly a lot. I do think it's kind of. It still feels a little bit fluid to me, not just in terms of the spec or things like that, because all that stuff's going. Like you said, you guys are gonna break stuff. So it's still, I don't know, infancy. But why do you think it's so difficult? Or why do you think it's so difficult to explain what WebAssembly is and to clarify and to? Because they're like now, so throughout this entire conversation, it's like, okay, all right, that makes sense. But when you first explain it, it doesn't sound perfectly clear. Do you think that there's a I don't know, like a teaching tool or a very simple way that we can start teaching people what WebAssembly is, other than, because like I know like the like ASM.js has like a facts list. Is that all it is? Is just from me like, okay, this is the question you have, this is the answer, or is there more like intuitive way that people can start learning about this stuff?
Well, I think right now we have a lot of docs that are being used within the community group, kind of just to record decisions, but they're really not oriented towards onboarding kind of random people. And so I think one of our jobs is, once these ideas stabilize enough to even start writing about them, we need to write a set of like really good tutorials for people coming from different places, like WebAssembly for web developers, WebAssembly for C++, portable C++ programmers, and WebAssembly for if you want to write your own compiler to WebAssembly. And so I think in the next coming months, it will only have reached a point of stability where we even can write those tutorials without them being totally inaccurate, a month later. But that is a major job of everyone in the community groups to help explain this. But I would totally understood that it's pretty weak right now. Like the new person getting into it is use cases.
So I have a follow-on to that. If people were getting really, really excited about what they're hearing and they want to do something now, is there anything they can do now? Is there anything to play with? Are there any other than reading the posts that we've read?
Yeah, there's a couple of things. One is we have a design repo which has a bunch of markdown, sort of natural language descriptions, and we also have what's called a spec repo, which contains a reference interpreter of WebAssembly written in ML, and it's trying to be written in like a specy way that kind of looks like you might imagine a spec pseudo algorithm to look like. And so you can actually run that. You have to install OCaml, but you can run that and write some WebAssembly programs in this S-expression temporary text language and run them. And we get a lot of people playing around with that and filing issues on the spec repo and learning about that way. And you can also see, and sometimes the best way to learn is there's a big test directory, which are tests we write against this spec interpreter, and you can read those. And it's like, here's a module. If you run this, it should give this result. And that's another way people kind of learn what are the concepts here, is by reading the tests.
Right, and I think one interesting thing is, if you're a language geek or whatever, and you have your language that you'd like to run on the web, well, it'd be interesting to have other languages in C and C++ start to try using WebAssembly at some point in time, right? So generating that S-expression format and running on the spec repo or something like that. Now, with the caveat that initially it's designed to mostly cater to static languages, but for example, if someone wanted to compile Fortran to WebAssembly, I'd be really happy. Fortran is actually a cool language. I like Fortran. And seriously, it'd be a pretty decent target for WebAssembly, and would hit kind of different feature sets than C and C++ do. But there are a bunch of other kind of static languages that, for the very early version of WebAssembly, I think would be kind of well suited to target WebAssembly. And I think what we've designed, the VM and everything, would be better off if we don't just do C++, but we're doing these other languages, right? And that's something that we want to happen before we kind of stamp the MVP, first version label on WebAssembly. And that's something that we can't do just on our own, right? We'll do some of it, but it'd be great if more people did that.
Well, and there's a drive for other languages on the web, right? I mean, you do see other people who, want to bring sort of their go-to language to the web. So and I think this is one of the keys to the entire WebAssembly sort of spec process that's going on right now, is that there is that flexibility built into that MVP right now, is that it's not while it is targeting right now for C, C++, there is this future vision where I want to bring XYZ to this. That's there now. This is the plan, that it's not just this is the one-shot deal, this is what it's going to be. It does have that extensible feel to it.
Does anybody think that we might, so MVP's out, version 1 is out, and then we start getting people writing more and more languages, not new languages, but Java and C# and whatever else you can think of that now compile into WebAssembly. Do you think that the web development community, that there's the possibility of the web development community fracturing at all? Because right now, if you are a front-end web developer, you write in JavaScript. Everything is this. The way that you do everything is the same. Do you think that there is a risk of people fracturing into a bunch of different camps? I mean, people, I guess, have kind of done this now, where some people write in TypeScript and some people use Babel so they can write ES 2015 code, and people just write vanilla. So I guess it's already there a little bit, but do you think that this will take it even further, or do you think it will just make it easier for more people to start in on web development with a language that they're already comfortable with?
I think for at least the coming small number of years, JS will still be the right language to use for most web development, so it won't cause any fracturing, and if people are generating WebAssembly kind of directly, then it would probably be through a language, some variation of a language like TypeScript, which would need itself extensions, but that's, as you said, that's already being used, and it's designed to not fragment the web community because it is still based on JavaScript. It's just gradual typing. So I don't see that happening.
Okay, that's totally valid. So does anybody else? We're getting close to our hour mark. What's something I don't know about WebAssembly? After all of this, what is something that somebody like me who has a vague understanding, what's something important for them to know? Or just something cool. It could
What's
be
the
anything.
killer feature? What do you guys think is going to be the killer feature?
Well, I think it's really about offering the hardware's capabilities to the programmer, right? Being able to really express what you want and get predictable performance out of it, right? So you know, being really close to the metal, being able to execute exactly what you want on the hardware, and through that, you know, being able to, you know, compute more things or have a game that runs faster or something like that, but also save battery life. I think that's kind of the killer feature that WebAssembly enables, and it does that by being really, you know, cognizant of how the hardware works, but also how higher-level languages end up mapping to that, right? So it kind of is in the middle of those two things and tries to, you know, fit really well in that niche. I think that's the main killer feature that we have.
Performance is huge.
I think cold load time on mobile is going to be a big deal for WebAssembly. And even though it's not in V1, it's in the real soon after V1 list, which is shared memory multi-threading. It's going to be another important thing.
I think apart from those two, right, from the performance perspective, I would say the interoperability of languages with JavaScript, right? I mean, that's one of the big things that, you know, WebAssembly is going to bring to the web.
Yeah, no, the performance factor is huge,
yep.
especially on mobile, because right now you have to, especially if it's just JavaScript, if you're not talking about actual DOM rendering and things like that. JavaScript on the desktop is decently fast by comparison to other, you know, to like C. It's not fast, but it runs pretty fast. Where you start to really notice performance problems are on mobile. And so having any way to potentially speed that up or give you just make it faster. Faster on mobile is always good.
Yeah, and it's also memory management, right? I think WebAssembly will allow you to express exactly how you want to use memory. And of course, you can make a mess in any language, but you get much more control and predictability through WebAssembly. I think that kind of feeds into performance as well. And on mobile, you know, memory usage is a huge thing.
Yeah. So honestly, this is kind of really off the rails, but now I'm thinking about it. So how does WebAssembly manage memory? I just thought of something. I'm curious. So how does WebAssembly manage its memory? Because, you know, JavaScript, it just kind of all happens, and a lot of higher level languages it just happens. But then, like, if you're talking about, you know, something like C, you have to do it on your own. So how does WebAssembly I guess not how as the developer do you manage memory with WebAssembly?
Yeah. So that's how WebAssembly v1 is really focused at low level languages, and therefore not really suitable for the high level languages, like, you know, compiling from like Java. In that you manage it the same way you do kind of in C and C++. There's explicit allocation and release. And what's going to happen is WebAssembly, the spec itself, defines this big contiguous range of memory, and you basically just grow the size of it. And then on top of that linear memory, you would implement like a malloc or a free or whatever you would do in C or C++. So very, very explicit. But if the future in the roadmap going towards GC, then you wouldn't have to use that big linear memory. You would be able to use just straight up GC references in the same browser GC that you have with JavaScript. So then you'd be able to, then it would feel just like, you know, GC allocation and you know, the browser cleaning it up for you.
Okay. Yeah. No, I'm sorry to completely go off the rails for kind of what we were talking about, which is what is WebAssembly and what is it good for, but I was realizing I should have said it's another way to think of it is like in WASM.js you have this big array buffer, one big array buffer, and that's all your bytes. And in WebAssembly you could say you could think of it sort of the same way, except that array buffer can grow. Very cool. Yeah, so we're very close to our time. So does anybody have any parting thoughts that they would like to throw out to our audience? Going once, going twice, and okay, that's fine. So look, thank all you guys for hanging out with us today, dealing with all the technical difficulties and stuff. I really appreciate it. WebAssembly is a really fascinating spec. It's a very interesting way to think about the future of web development. So, we're pretty much going to do the same thing we did at the very beginning. Just go around the room. If there's anything you want to plug, if there's any, like if people want to help contribute. If people want to help contribute to documentation, anything like that, how can they do that? How could they get in contact with you guys if they have questions, etc.?
Yeah, I think the best way is on the W3C community group. Just join the group and then go on GitHub. We open issues or stuff like that, read through documentation. And as Luke said, we haven't done the best job ever at documenting everything. So helping us, new people coming in, show us where we failed at documenting things well, right? So questions or pull requests or something like that are tremendously helpful.
Awesome. Yeah. No, documentation is huge. We've talked about that before when contributing to open source projects. A lot of time they need help with documentation. So if you want to contribute, that is almost always a place that you can have some input. All right. And so, again, thank you guys very, very much. This has been episode 78 of the Web Platform Podcast, The State of WebAssembly. Fascinating stuff. Do some research on it. We will put some links in the show notes. And yeah, thank you guys again. You guys are doing awesome work.
Thank you.
Thank you.
All right.
Thanks.